In this video, we are going to look at the Profile Analyzer package for Unity 2022 LTS. Profile Analyzer gives structured, analytical data across a range of frames in your game, and is used to monitor performance and identify where optimization techniques are required. It can be used to compare against two sets of data and analyze performance differences. If you want to follow along with this video, you can create a new project in the Unity Hub and download the URP 3D Samples Scene template. It features environments to help you learn how to use URP optimally across all platforms. It has 4 environments, each with different art styles, rendering paths, and scene complexity to represent the variety of 3D projects built with URP. Profile Analyzer should be installed from the Package Manager under Unity Registry and find it in the list. Click Install at the top right. It can now be opened from Window, Analysis and Profile Analyzer. This works alongside the Profiler, so open that from Window, Analysis and Profiler. I'm using the Oasis scene from the URP 3D Samples, but you can use any project you like. Profiler is ready to record, so as soon as I begin playing, it will record frame by frame data. Then click in CPU usage to pause the game. Now we can pull that data into the Profile Analyzer. Change the timescale to make the data easier to see. Profiler is used to inspect individual frames. The Profile Analyzer, however, is used to inspect a range of frames and automatically prepares analytical data arranged in the sections we see here. They work closely together to allow a deeper look at frame performance in your projects. The frame summary is showing a range of 300 frames selected and displays the max frame in milliseconds, which is the tallest spike, the minimum frame, the median frame, which is the midpoint between the max and min values, and the mean, or the average frame. There are buttons by the max, median and min frames. If we watch the Profiler, as I click on the median button, it moves to that frame in the Profiler and allows for a deeper inspection of the median frame. Maximize this window and click and drag to select a range of data covering these spikes. It will now automatically update the analysis for that selected range. Right-click on the range and choose Zoom Selection for it to zoom in on those selected frames. The blue is the selected profile marker, which in this case is the editor loop. Clicking on a different marker, the blue section changes, displaying how much that marker is taking per frame, and we can visualize the spikes of this marker. The frame summary is now updated, showing the max, min, median and mean values for these 105 frames selected, so you can be selective over which frames are to be included in the analysis. The bar chart is showing where most frames are taking place between 0 and 14 milliseconds. The top 10 markers are chosen from the median frame. These are the 10 markers that are taking the most time to complete. Clicking on one of these updates the marker summary. This is specific data related to that individual profile marker. It displays the top 3 frames by cost, and you can click on these buttons to jump to those frames in the Profiler. You can select up to a maximum of 10 frames for each marker. This may be useful if you are looking for patterns where this marker is spiking across the range of frames. Then a bar chart of where most of these frames are in terms of completion in milliseconds. Bars to the left are preferable as they are completing quickly. And we have the max, median, mean and min for this specific profile marker. We can right click and choose Zoom All to zoom back out to view all frames. You can also clear selection. With no frame selected, there is no analytical data. Right-click to select the shortest frame, and now the data can be used to see stats about a single frame. You can also choose the median frame or longest frame. Choosing Grow Selection will increase it by a single frame at either side of the range, or Grow Selection Fast, which selects more frames. You can also shrink a selection if you want to narrow your focus down to a smaller sample of frames. You can also right-click and select all, but this will include the frames at the end where we stopped profiling. Those largest frames at the end are skewing the data, so I would recommend selecting your own range and excluding those frames at the end for more accurate data. We are at the moment profiling inside the Unity editor, so the running of the editor is combined with the running of the game, giving inflated values. For more accurate data, it is recommended to profile from an external build, and for mobile, on the intended mobile device itself. By default, it is set to capture 300 frames, which in most cases is sufficient. However, if you do need a larger sample of frames, you can go to Edit, Preferences, and under Profiler, you can increase the frame count here. We are analysing totals for our profile markers, so in the profiler we can see this for something like the player loop, where it shows 29% as a total, but only 0.5% as self. Total is combining all the markers that sit underneath the player loop, which is why player loop is often the largest, as there are a lot of markers listed here. The render pipeline manager has a total of 24.2%, which is the combined values of all these markers that sit underneath it. We can view the markers as either total or self. Now we can see the player loop further down in the list. This can be useful to find the individual markers that are taking the most time to complete. By default, we are only analysing the main thread, but we can choose multiple threads. There's a total of 76. You can select whichever threads you want to analyse either on their own or together as a group. For example, I might include the render thread and press apply. Now it is presenting the profile markers for both main and render threads. The thread summary will give the median time in milliseconds for the selected frames and can be a quick way to identify if any threads require optimization. We can also filter the profile markers. If we know exactly which marker we want to see, we can type the name of it in the name filter, and it will now just show that one marker and present information specific to that. Remove the name from the filter to return to all markers. We can right-click on a marker and choose Remove Marker, and it is removed from the analysis. Now this only allows you to remove one marker at a time. We can choose None from the drop-down to return the marker. If you want to remove multiple markers, right-click and choose Add to Exclude Filter, and you can do that with as many markers as you like. This is useful to customize the data you want to analyze. Remove the text in the Exclude Names to return the markers. In the timeline, we can see different profile markers are happening at different depths. At a depth of 1, we have the player loop and editor loop. We can choose to view markers on the individual depth slices, so depth slice 1 is just going to show us the profile markers at the top depth for both the main thread and render thread. Or depth slice 4 will show this line and the markers that appear here, giving us more granular detail on the performance of the frames. We can choose to present the marker details in a variety of ways using the Marker Columns drop-down. There is also Custom, so you can define your own marker details. Right-click on the column headers to define which columns you want to show. If we click on Compare, it allows us to compare two sets of data. With data already in the single category, it will auto-fill both top and bottom with the same data. If pair graph selection is not checked, I can now click and drag to define a range of frames from the top set of data and a different range of frames from the bottom set. Now I am comparing the taller spikes against a section that has smaller spikes. This is useful because now I can discover what is causing these spikes, as the differences between the two will be visible in the analysis below. The blue section is the top set and the orange section is the bottom set. The frame summary shows that the difference between the two at maximum is 6.69 milliseconds and at average is 1.35 milliseconds. The differences between the two are presented as bars in the marker comparison. Blue bars go from the center to the left and show the differences of the first set. The orange bars go from the center to the right and show the difference of the second set. With player loop selected, we can see the top frames by cost. This marker is staying at a difference of about 2.5 and 3 milliseconds for the top 3, but here we don't have the frame buttons, as they are different frames for set 1 and set 2. Looking at the profile marker names, we can see that the major differences are in the rendering, so that would be the area we would focus on to reduce those spikes. We can load or save data into the Profile Analyzer in both single and compare modes. This is useful for a comparison of before optimization and after optimization to ensure the changes you have made are having a positive effect on the performance. It is also useful for presenting data at meetings, because saved data can be transferred from one computer to another. Now if I have data in the profiler and I maximize the profiler window, then unmaximize it, the data disappears from the Profile Analyzer. So it's a good idea to save important data from the Profile Analyzer. In the profiler we can load any previous profiles. This is from the garden scene, and I want to compare against the oasis scene. In compare mode, I want to pull this into the second set, then load saved data from the oasis scene into the first set. It will then compare the two sets of data. Normally you would compare against the same game, but for demonstration purposes, I am comparing against two different scenes intended for different platforms. Major differences between the two are expected. When you have two different sets of data, pair graph selection is checked. So now when I click and drag, it will select both sets at the same time and ensure the range of frames matches between the two. Now we can filter this data, changing the analysis type to self, and remove the editor marker and add any profile markers to the exclude filters, which will then give more accurate data comparisons. The largest difference between the two is the apply shader, with a difference of 0.58 milliseconds for the garden scene. For the top 10 markers, if we choose longest instead of normalized, we get a visual of the difference between the longest markers on the median frame. In the marker summary, it is shown in the bar graph where most of the frames are in terms of milliseconds, between 0.212 and 1.3113. This evaluates the difference in a very easy visual format. Compare data from different parts of your game, particularly where you have more characters on screen at any one time, and see how performance changes from parts where you only have your main character roaming around. Check parts where you spawn objects or characters in to see if it creates dips in frames per second, and identify how to optimize. Compare after playing for 30 seconds against after playing for 30 minutes to see if there is a difference in performance based on any system throttling. This is very important for mobile devices that do heat up over time. Compare against different levels of your game to ensure a consistent performance throughout the entire game. Compare against different hardware, for example 2 desktop PCs with different CPUs, different graphics cards and different amounts of RAM. Or 2 desktop computers with different operating systems, for example Windows against an Apple Mac, or Android against iOS on mobile devices. This will also help you to define the minimum and recommended specifications for playing the game. And that brings us to the end of this video. We have looked at how to pull data into the Profile Analyzer from the profiler and also using the saving and loading buttons. We have discovered how to read the selected data and how to filter that data. We have looked at comparing data and identifying differences in performance. To discover more about profiling in Unity, download the ebook in the description below. Thanks for watching.